Let us take the next example where we have two zero mean Gaussian random variables x and y are added. That is w is equal to x plus y, and their variances are sigma x square equal to 3 and sigma y square is equal to 7. It then follows from the 3.88 that the characteristic function w will be this value. That is because of the reason that we need to just take the what we call characteristic function of the zero mean Gaussian random variable. Now let us see that in the appendix. So this is the Gaussian random variable's characteristic function. If this is zero mean, then we'll have this quantity equal to 0, and we are left with exponential of minus omega square sigma x squared by 2. Now, if I write what you call phi of w over here, then this will become omega square sigma w squared by 2. And sigma w square will be equal to sigma x square plus sigma y square, because we have the x plus y, and x and y are both the independent random variables. That is what we have already derived. So therefore, the sigma x square plus sigma y square in the equation which we have just considered here is 3 plus 7, and that becomes minus 10 w squared by 2, and this minus 10 by 2 will become 5. Again, mu x, we have mu w will be equal to 0, because mu w is equal to mu x plus mu y will be equal to both mu x and mu y will be 0, because we have zero mean Gaussian random variables. Now let us take the next example of where we consider verifying the convolution integral in the 3.84 using the information given in the figure in 3.10 by first integrating y from minus infinity to plus 1. Now this is the convolution integral which is mentioned over here, right? So first we take the CDF of w. CDF of w is equal to p of x plus y, w less than or equal to w, where w, capital W, is x plus y, and minus infinity to infinity. Now this quantity is minus infinity to w minus 1 fxy xy dx dy. And because the xy are independent variables, we can separate this out as fx of x and fy of y. And once we separate, and then we can totally the change of variables you can try to apply, and then take the fy of y over here, because it is not dependent upon x, and this quantity we can just write minus infinity to w minus y fx x dx, and this will be dy. Now the CDF, if you differentiate with respect to w, you'll get the PDF. So d by dw of fw. So if you differentiate the CDF, then you'll get the PDF, and that is the PDF of the W function is equal to the differential of the CDF function, and that just means that we are trying to differentiate this with respect to W. So W has nothing to do with the FYY, or FYY has nothing to do with W, hence we will not have that, and therefore we'll have differential of only this. Differential of integral will get cancelled with the condition that this x will be replaced by w minus y, and hence we'll have fx of w minus y. And this is nothing but the convolution integral which we have over here. Now let us go to the next problem, wherein we have x is a random variable which is uniformly distributed between 0 and 3, and y is the random variable which is independent of x, and which is again uniformly distributed between plus 2 and minus 2, and w is equal to x plus y. So here the range of values of x are 0 to 3. So range is 3. Here plus 2 to minus 2. Y, the range is 4, and we can try to solve it from the first principles. So so fxx looks something like this from 0 to 3, and the area under the fxx, the PDF should be equal to 1, and therefore the magnitude of the fxx should be equal to 1 by 3. Similarly, Fyy is between -2 to 2, and the area under the, again it is uniform distribution, the area under the Fyy should be equal to 1. Therefore, this should be 1 by 4 because the range of values are, -2 to 2. That is the what we call, this range is 4 units, and therefore the magnitude of this will be 1 by 4. Next, what we do is we just try to flip or take the rotation of this, or take the mirror image of this with respect to the y-axis over here. So we'll get back the same figure. So fxx is kept as it is, fyy is flipped, that is fy of -y is found, and we'll get the same figure from -2 to +2 because this figure is symmetrical with respect to y-axis. And next, what we try to do is we try to reproduce this fxx over here as it is, but fyy we shift it to the left side of the fxx because we need to shift it by the value of w. Okay, this value we just write it to the left of the figure fxx. Then now, till the time this point comes on this, there will not be an overlap between these two. Till this point comes with respect to this, that means this is 0. Till the time 0 is equal to 2 plus w, till the time 0 is equal to 2 plus w, that is w is less than, till the time w equal to -2, 2 plus w equal to 0 will give w equal to -2. So till the time w is equal to -2, there won't be overlap. That just means that till the time w is less than -2, there won't be any overlap. When there is no overlap, the convolution value will turn out to be 0. Okay, they don't overlap at all, right? Then next, as soon as this point crosses this, then we'll have w which is greater than -2, or -2 which is less than w. W greater than -2 means -2 less than w. So as soon as crosses this point crosses this, we'll have partial overlap till the time this point, comes to this point. This point comes to this point. So -2 plus w equal to, when this crosses this, then there will be partial overlap till the time this crosses this point. Because this cannot cross this point, rather this crosses this point because this is units 3 and this is unit 4. You can see that this is the the units from here to here, from -2 to +2 will be equal to 4 units, and this is 0 to 3. So till the time this crosses this, from the point this crosses this point, and from this crosses this point, we will have the value. When this crosses the value 3, 2 plus w equal to 3 will give me w equal to 1. So from -2 till 1. So -2 till 1 will have partial overlap. Okay, we'll have partial overlap. And this quantity is nothing but, here this point is nothing but the 2 plus w. Okay, so the overlap is between 0 to 2 plus w. So that's why we have integral here 0 to 2 plus w. Then we'll have fxx and fyy. Fxx is 1 by 3, fyy is 1 by 4. So 1 by 4, 1 by 3 dw. So 1 by 12. The integral of dw will be w, 0 to 2 plus w, that will give w plus 2 by 12. So between -2 to 1, the value of fww will be this point. You can have dx here, dy here, does not matter at all, or dw here. Next, we have once this point crosses this, that means once w is greater than 1, right? Then we'll have full overlap till the time this point crosses this point. And when will this point cross this? -2 plus w equal to 0 will be the place at which it will just cross that, and that will be equal to w equal to 2. So for the values of w between 1 to 2, okay, there will be full overlap. Between 1 to 2. we'll have full overlap here. That is 0 to 3. 0 to 3 will be the overlap. So 0 to 3, 1 by 4 into 1 by 3 dw equal to 1 by 12. Then again you integrate it, the dw, you will get w here, and then if you simplify that, it will just give you 1 by 4. Once this range is over, then w should cross 2. So w should cross 2. That just means that, you know, this point, so rather you know, now we had between 1 to 2 full overlap, between 1 to 2 full overlap. Then this point crosses this, will get partial overlap. So this is, you know, we know that it is this point is 3 as well, and you know, this point over here, this is like this. Once this point crosses this, we will get partial overlap. That means this quantity is 2 minus, you know, minus 2 plus w. W minus 2 or minus 2 plus w is this point. Once that minus 2 plus w crosses this point, minus 2 plus w crosses this point, means minus 2 plus w is equal to 0. That is w equal to 2. It crosses w equal to 2. Then we will have the quantity, that is value which is greater than 2. So till the time minus 2 plus w crosses, from the point minus 2 plus w crosses this point, we'll have a partial overlap till again this one crosses this point, which is 3. So minus 2 plus w till equal to 3 will give w equal to 5. W equal to 3 plus 2, that will equal to w equal to 5. So from 2 to 5, we'll have the figure which is something like this, minus 2 plus w, and this will go to somewhere, you know, this will be 2 plus w. So overlap portion is this here. Overlap portion I have not hashed, but it is just this, from minus 2 plus w till 3. So from minus 2 plus w to 3, so the limits of integration will be minus 2 plus w and 3, 1 by 4 plus 1 by 3 dw or dx or dy, 1 by 12 w minus 2 plus w and 3 are the limits. Then if you try to solve that, 3 minus of 2 plus w, that is 5 minus w by 12. So this is with respect to flipping the f y y. If you flip the fxx, you should get the same result. That's another method. That's just another method, which is what is solved in the equation. So if you see the values there as it is, the values in the you know, over here, then those are the same values. W, that is between minus 2 to 1, it is w plus 2 by 12. Between 1 to 2, it is 1 by 4. Between 2 to 5, it is 5 minus w by 12. So let us see, this is the equation which he has written here is with respect to the taking mirror image of fxx rather than fyy. We have taken till now the flipping of the mirror image of fyy, or the rotation of fyy, and then shifting it. Now let us see by taking the mirror image of fxx and then shifting it. So, so that is the method 2, where we'll take the flipping of or the mirror image of or the rotation of fxx. If you shift fxx, or sorry, if you take the mirror image of fxx, you'll get here minus 3 to 0 in place of 0 to 3. Magnitude remains same, 1 by 3. Magnitude of this is 1 by 4. Now, what we do is we keep this as it is here, but we shift this over here and take it to the left of the fyy. This we shift it, and that is shift is means w minus x, and take it to the left of the figure which is over here. Now, till the time this, you know, as we move this figure over here, till the time w is not same as minus 2. That is, till the time w is less than minus 2, there is no overlap. Once there is no overlap, then the convolution is equal to 0 again. Once this point crosses this, there will be a partial overlap. Once this point crosses this, there will be a partial overlap. And since this, the number of units here is 3 and the number of units here is 4, right? The full overlap will occur only when this point crosses this. This point crosses this. So when this point crosses this, W minus 3 is equal to minus 2. That will give W equal to minus 2 plus 3, that is W equal to 1. So crosses W equal to 1 just means that, you know, it should be lesser than 1. So from minus 2 to 1, from minus 2 to 1, there will be partial overlap. From minus 2 to 1, there will be a partial overlap. That partial overlap will look something like this. From minus 2 to W. From minus 2 to W will be the partial overlap. So that's why the limits of integration here should be minus 2 to W, 1 by 4, again 1 by 3, dW or dx plus or dy, either of those three. Then if you try to solve that, you'll get 1 by 12. Then integration of dW will be W, and with limits W and minus 2, and that will give us W plus 2 by 12. Now, the next range is greater than 1, W greater than 1. And that greater than 1 will occur when this point crosses this point. Once this point crosses this point, we'll have full overlap. Full overlap till the time this, you know, crosses this. This crosses this means when W is equal to 2. From W equal to 1 till W equal to 2, there will be full overlap. And that is what we have here. From W equal to 1 to W equal to 2, that is 1 less than W, less than 2, will have full overlap, and full overlap is between W minus 3 to W, W minus 3 to W. So limits of integration is W minus 3 to W, 1 by 4 into 1 by 3, dW equal to 1 by 12 into W limits W minus 3, W, and then if you try to solve this, you will get 1 by 12 into 3, that is equal to 1 by 4, not multiplied. It is equal to 1 by 4. It's not multiplied. Please note that. Next, once now we have here 1 to 2. Once the W value crosses 2, that is the next range. W value crosses 2 will just be corresponding to this point crossing this point. At that time, we'll have a partial overlap. And that partial overlap will be there till this point crosses this. This point crosses this just corresponds to W minus 3 is equal to 2, and that will be W equal to 5. So till the time W equal to 5, from W equal to 2, we'll have partial overlap. And that is what we have here, 2 less than W less than 5. We will have a partial overlap, and that partial overlap will be between W minus 3, W minus 3 to 2, W minus 3 to 2. So therefore, limits of integration would be W minus 3 to 2, 1 by 4 into 1 by 3, dW, 1 by 12, W minus 3 to 2, equal to 1 by 12, 2 minus of W minus 3 will be the substitution. If you do that, then you'll get 5 minus W by 12. That's the value. Now, this is as soon as W crosses the 5 value, then there won't be any overlap. No overlap above 5 will give us the FW, W equal to 0 above W greater than 5. So therefore, if you see this, this is what is the solution we have put, you know, in the figure, in the what you call in the solution over here. Okay, same equations, minus 2 to W, W minus 3 to W, W minus 3 to 2, and the equations are just the same and 0 otherwise, right? So this is how we can try to solve the problem which we have just specified. Let us take the next problem. Okay, let us take the next problem. Let the random variable U be the uniformly distributed between plus or minus 5. Also let the PDF for the random variable V be this. Now this is an exponential function, 3e to the power of minus t, 3v, uv is the exponential function, whereas u is the uniformly distributed between plus or minus 5. Range of values are from minus 5 to 5. So definitely uniformly distributed means magnitude will be equal to 1 by 10. magnitude will be equal to 1 by 10. So let us see the solution for that over here from the first principle. So here FUU is from -5 to 5 uniformly distributed. So the duration is 10 over here. So magnitude should be equal to 1 by 10. So that area is equal to 1 under the curve of the PDF. Then we have the what you call FVV as this function, exponential function, right? Exponential function, whatever exponential function which we have written over here. 3 e to the power of minus 3v uv, that is, if v is equal to 0, then this will become 3. If v is equal to infinity, then this will become 0. So exponential fall will be there as it is over here, right? So this is FVV. So once we write that, now what we try to do is we'll try to flip this or rotate this or take the mirror image across y, whatever you call it, but still you'll get the same because this is a symmetrical figure. So fu of minus u is just this, -5 to 5, 1 by 10. Take the mirror image of fuu across the y-axis. Then we will put this figure, if they put this figure as it is over here, and then we'll have to shift this. So starting point for shifting should be, we should keep this, to the left of this figure. We should keep this to the left of this figure that is here. So this shifted, this value which is shifted over here will give us the value which is f of w minus u. That will give here 5 plus w, here w minus 5, here w plus 5, here w minus 5, or minus 5 plus w, whatever you call it. Minus 5 plus w, 5 plus w. That will be the value over here. Now, till the time this point matches this, there won't be any overlap. That means this point matches this means w equal to minus 5. Till the time w equal to minus 5 means till the time w is less than minus 5, there won't be any overlap, and hence convolution will be equal to 0. Convolution will be equal to 0. Then next, between, once this crosses this point, there will be partial overlap till the time this crosses this point. Once this crosses this point, there will be partial overlap till this crosses this point. So this crosses this point will be giving us w equal to minus 5. This crosses this will give us minus 5 plus w equal to 0, that is w equal to plus 5. So from minus 5 to plus 5, there will be partial overlap, and that is what is written over here. Minus 5 to plus 5, there will be partial overlap, and the partial overlap will have a common portion between 0 and 5 plus w, 0 and 5 plus w. So therefore, limits should be corresponding to this, that is 0 to 5 plus w, 0 to 5 plus w. The value of FUU is 1 by 10. The value of FVV is 3 e to the power of minus 3w. And those two we are writing over here, 3 by 10 e to the power of minus 3 w by, integrate this over here, 3 by 10 you can take out, integrating this, we'll get 3 e to the power of minus 3 w by minus 3 with limits 0 to 5 plus w. And if you, 3 will cancel, we'll get minus 1 by 10. And if you substitute in place of w 5 plus w, you'll get this. If you substitute 0 for w, you will get e to the power of 0, that will be equal to 1, and hence we'll get like this, and minus you can take inside and you'll get 1 by 10, 1 minus e to the power of minus 3, 5 plus w. Once this point crosses this, so next range is plus 5 and greater than plus 5. So here now it is minus 5 to plus 5. Next range is w greater than 5, and w greater than 5 will occur when this point crosses this. Rather, this point crosses this. Then will be full overlap. Okay, there might be full overlap. Okay, but however, that full overlap might not be the total case, depending upon the situation of the figure over here. So we'll see what it is. Okay, so once we write that, we'll get something like this. Once we write this, we'll get something like this. So w greater than 5 will be something like this, which will be w equal to f, that is limits will be from minus w minus 5 to w plus 5. Okay, that will be the hashed portion over there, full overlap, w minus 5 to w plus 5, 1 by 10, 3 e to the power of minus 3w dw. So only limits are changing, the inside value is not changing. So we'll get the inside value as it is, only limits are different. Hence, we'll get the equation which is at the end like this. Okay, so this gives us the solution for that problem. Now let us go for the next problem, which is the random variable x has a PDF of c into 7 minus x for all values of x between 0 to 7 and 0 otherwise, and y is independent of x and is uniformly distributed between 0 to 7. So y is uniformly distributed between 0 to 7, whereas x is c into 7 minus x. So if you plot this c into 7 minus x, when x is equal to 0, then this will be 7c, and when x is equal to 7, this will be 0. Okay, this will be 0. So this is a equation, this is like equation of a straight line. You can see that it's the equation of a straight line. So let us see the solution for that. So when x is equal to 0, it is 7c. When x is equal to 7, it is equal to 0. So that will become a, falling straight line like this. So fxx will be like this, where fxx is c into 7 minus x. X equal to 0 will give me 7c. X equal to 7 will give me 0. And that is what we'll have over here. Now, this is a triangle. The area of the triangle should be equal to 1. Area under the curve of the PDF should be equal to 1, and the area of the triangle should be equal to 1. And that will give us half of 7 into 7c is equal to, this should be equal to 1. Half of 7 into 7c is equal to 1. All this is multiplication. So c will give 2 by 49. C will be equal to 2 by 49. Okay, this will be 49c by 2. So c will be 2 by 49. Right. So this quantity is 2 by 7c will be 7 into 2 by 49. That will be 2 by 7. Now we'll try to flip the fyy. We'll try to flip the fyy, flip or rotate or take the mirror image across the y-axis, right? That's what we are trying to do over here. And then we try to shift this, keep this fxx as it is. So that just means keep the fxx as it is and shift this now. Shift this now means we'll keep this on to the left of this initially. Okay, we'll keep this to the left of this initially, so that after shifting. So 0 gets to w, and minus w will go to minus w plus minus 7 plus w. Minus 7 will go to minus 7 plus w, that is w minus 7 over here, and 0 will go to the w. Okay, so from w minus 7 till w, or from minus 7 plus w till w will be the values for the fyy, which is uniformly distributed. Uniformly distributed between 0 to 7. Area should be equal to 1. So therefore magnitude is 1 by 7. Uniformly distributed between 0 to 7. Area again should be 1. Therefore magnitude should be 1 by 7. That's why here also 1 by 7. Here also it should be 1 by 7. So when till the time this does not overlap this, as we shift this, as this we have to shift now. Okay, as we shift this, till the time this does not overlap this, we will have, that is w less than 0. There won't be any overlap between the two figures. When there is no overlap between the two figures, then naturally we will have w, which is the fww will be equal to 0. The convolution will be equal to 0. Once this point crosses this, we'll have a partial overlap. Once this point crosses this, we'll have the partial overlap till the time this crosses this point. This crosses this will give w equal to 0. This crosses this will give me w equal to 7. That is w minus 7 equal to 0 will be w equal to 7. So from 0 to 7, for the values of w between 0 to 7, there will be partial overlap, and that partial overlap will look something like this. That means this should be the hash portion. between 0 to w. Limits will be 0 to w. So between 0 to w, it will be 1 by 10 multiplied by 2 by 49 multiplied by 7 minus x into dx multiplied by 7 minus x into dx, and this will be 2 by 343. 7 minus x will be integrated, will be 7x minus x squared by 2 with limit 0 to w, and we can just substitute the limits, and at the end we'll get 14w minus w squared by 343. Now, once this point crosses, then once this point crosses this, there will be a total overlap. There will be a total overlap. So range will be again between 0 to 7. There will be a total overlap, but how that total overlap might remain for a very short duration of time will be just at the instant, right? But however, once the value of w crosses this, then once this crosses this, there won't be total overlap, but overlap on this side. So we'll have the figure which is something like this. For 7 less than w less than 14, less than 14 will just correspond to this point overlapping with this till the time this overlaps with this, and from the point this overlaps with this, that is w equal to 7, till the point time this overlaps with this, that will be w minus 7 equal to 7, that will give w equal to 14. From 7 to 14, we'll have a figure which is something like this. Okay, so here you can see that the overlap portion is w minus 7 to 7, w minus 7 to 7. So w minus 7 to 7 is the limits of the integration. 1 by 7 inside quantity will not change, will remain same, only limits change. So again, 2 by 343 is taken out, and this is integrated. Limits are w minus 7 to 7, and if you totally get it, we'll get something like this. For w greater than 14, no overlap, therefore w is equal to 0. w is equal to 0. If you see here, we'll get the same, we have the same expressions, whatever we have in this case.